Hello everyone, in this video we would be talking about the three equations of motion and how they are being derived. There are two ways of derivation. First we will be talking about the algebraic method. Now for a uniform acceleration we have these three equations of motion which relate initial velocity u, final velocity v, acceleration a and time of journey t and distance travelled s. The equations are v equal to u plus at, the first equation. Then we have s equal to half u plus v multiplied by t, or ut plus half at square. And finally we have the third equation of motion, v square equal to u square plus 2as. So now let's see how we can derive them. Just consider the linear motion of a body with an initial velocity u, and we assume that the body accelerates uniformly and in time t it acquires the final velocity v. Then what we know is acceleration is equal to change in velocity upon time taken. Now acceleration is denoted as a is equal to change in velocity can be written as final velocity minus initial velocity. So final velocity is v, initial velocity is u. That's how we have v minus u divided by time taken, that is t. Then we cross multiply. So we get at is equal to v minus u. If we bring minus u to the left hand side, we get at plus u equal to v, or v is equal to u plus at. Now this is the first equation of motion that we have derived. To derive the second equation of motion, we are using this formula: average velocity is equal to distance travelled upon time taken. Now from this formula we know that distance travelled would be given as average velocity multiplied by time. Distance travelled is denoted as s equal to, the formula for average velocity is initial velocity plus final velocity divided by 2 multiplied by time. So if we take 2 outside, we have s is equal to half u plus v multiplied by t. So this is this equation. Now if we substitute the value of v from the first equation, that is v equal to u plus at, v equal to u plus at. So instead of v we are substituting u plus at, and then we simplify. So we get s is equal to half, we have multiplied inside, so u plus u is 2u and at upon 2 multiplied by t. If you simplify it further, you get 2ut plus at square upon 2. Then we write the denominator individually, 2 and 2 cancel out, this 2 is left, so we have s is equal to ut plus this 2 we are writing separately as half at square. So this is the derivation for this equation. Now to derive the third equation algebraically, we again use the same formula: distance travelled is equal to average velocity multiplied by time. So we know that this will be written as s is equal to u plus v upon 2, that is the formula for average velocity multiplied by time. Now in the previous equation we had substituted the value of v. In this case we are going to substitute the value of t from the first equation. What do we have as the value of t? See here, v is equal to u plus at. So from here we calculate that t is equal to v minus u upon a. So you see here s is equal to uv divided by 2, u plus v divided by 2 multiplied by, instead of this t we are substituting the value of t from the first equation, that is v minus u upon a. Now u plus v can be written as v plus u, because a plus b is equal to b plus a. So we just rearrange the terms. So we have s is equal to v plus u upon 2 multiplied by v minus u upon a. So 2 into a becomes 2a, and v plus u and v minus u becomes v square minus u square, because a square minus b square is a minus b multiplied by a plus b. So equation reduces to s is equal to v square minus u square upon 2a, and if you cross multiply it becomes 2as is equal to v square minus u square. If you rearrange the terms, that is, you take minus u square to the other side, you get v square is equal to u square plus 2as. This is the third equation of motion, hence derived. We would be talking about the derivation of equation of motion from graphical method. Okay, and for this graphical method we will be taking help of velocity time graph. So just consider the linear motion of a body having initial velocity u, and the body accelerates uniformly in time t and acquires a final velocity v. So from velocity time graph, the body would be represented by the line AB, that is straight line AB, and all these dotted lines, what we have done is we have made the construction. So it's evident that initial velocity is this distance OA, so that is equal to u, and final velocity is when the body reaches point B, that corresponds to point OC. So OC is equal to v. Now we try to derive the equation of motion. So for the first equation, that is v equal to u plus at, we know that the velocity time graph, if you consider velocity time graph, the slope of the line gives us the acceleration. So here we have written acceleration is equal to slope of line AB. So acceleration is represented as A, and slope of line AB is nothing but BE upon AE. BE upon AE. Now BE is same as AC and AE is same as OD. So OD is represented as, that is the time duration D. Now again AC can be written as, AC is this distance or this length, so this can be represented as the total length minus OA. So the total length is OC minus OA. Now the value of OC is V, so we write V, minus the value of OA is U. So V minus U upon the value of OD is T. So we have A is equal to V minus U upon T. You cross multiply, you will get AT is equal to V minus U, or V is equal to U plus AT. That is the derivation of first equation of motion. Now for the second equation of motion, that is S equal to UT plus half AT square, we know that the area enclosed within the graph gives us the distance traveled. So here we take distance traveled is equal to area of trapezium OABD. OABD means this area. Now if you look properly, this area can be divided into two areas, that is area of this rectangle plus area of this triangle. So as you know, area of rectangle is given as length into breadth, plus area of triangle is given as half base into height. Substituting the value, you have length into breadth as U multiplied by T, because OA is U and OD is T, plus half base is BE. So BE we already know from here that BE is equal to V minus U. So we simply write V minus U multiplied by AE. AE is same as OD, so that will again be T. Now if you simplify, you get S is equal to UT plus half. Now V minus U, from here we get AT. So we have written, since V minus U is equal to AT, we have substituted V minus U as AT multiplied by this T. So if you simplify again, we get S is equal to UT plus half AT square. That is the second equation of motion. Now for the third equation of motion, we again use the same formula. Distance traveled from the graph will be the area enclosed within the graph. But this time we have distance traveled equal to area of trapezium OABD, same like the previous case. But in previous case what we did was we divided the trapezium into two parts, that is a rectangle and a triangle. But now we will simply apply the formula for area of trapezium only. So that you know that distance traveled S is equal to area of trapezium. The formula is half sum of the sides multiplied by the height. So we have OA plus DB multiplied by OD. Now from the graph you know that OA is U. So we have written here U. Then DB. This is equal to OC and that is equal to V. So we have written here V multiplied by OD. OD is nothing but T. So we get S is equal to half U plus V multiplied by T. Now we go back to the first equation, that is V is equal to U plus AT. And from here we find out the value of T, which comes out to be V minus U upon A. And we substitute this value here. So using the value of T from equation 1 we get S is equal to half U plus V multiplied by, instead of T we write V minus U upon A. So here what we have done is we have used the formula of A square minus B square. You see A minus B and A plus B gives us A square minus B square. Then 2 into A gives us 2A equal to S. So if you cross multiply you get 2AS is equal to V square minus U square, and just rearrange the terms, then we get the third equation of motion, V square is equal to U square plus 2AS. Thank you.